and as the participant will join at the sufficient distance, then we will jump to our today's agenda. Okay. So if you have any problem regarding the previous session where I have touched about the visualizations, machine learning, some basic commands, live editor, that part you are using it very frequently, and for maybe you maybe select some topics for your PhD. So if you have any problem, anything, please let me know. So I can also understood that some madam was there yesterday. They have asked me multiple questions, so I have answered them. Okay, so I have given a 1-2 task to make this FDP more effective. I have given a that one assignments that the participant must I can't say the must word, but whether you have tried or not, that is an important for me. MATLAB on RAM and machine learning on RAM, these 2 tasks I have given to you. So whether you have started or not started, just let me know whether you have completed 10%, 30, 40, whatever. So this will give you the very good insight that you will understood to the MATLAB. Just anyone can tell me how much percentage you have completed. Even though you have completed the 0%, then please respond me, so I could make a more interactive way. So only one-way communications will just I would say that the synergy, it's a total synergy of lots of people. Okay, organizer, speaker, participants. Yes, that 2 tasks I have given you, you will get a very good insight. So some remaining parts was there. I will start shortly. Okay, so that the okay, fine. Okay, we move ahead. So just wait 1-2 minutes. After 1-2 minutes, I will start the where I have stopped yesterday. Okay, fine. So I'm sharing my PPT. Just give me a minute. Okay, fine. Okay, fine. Let me start. Please let me know whether my voice is audible, screen is visible. So just confirm me.
Your screen is visible and you are audible also, sir. You can start.
Yes, sir.
Thank you. Thank you. Okay, so let us start today. Yesterday we have covered Yesterday we have covered some part of the artificial intelligence or the machine learning. I have explained the regression part. Okay, I have taken one data sets and that I have explained you about that. Okay, and similarly I have talked about this. The today agenda will be the some classification part that I will be covered, and then later on I will jump to the deep learning part. Okay, so with the help of Deep Network Designer app, I will try to explain some pre-trained model, and then other things I will do in Google Net and AlexNet, which are the pre-trained model, what are the layers, and that we are going to do that part today I will cover. Okay, so this is my two agenda of the today session. So first we complete the machine learning part, that classification part was remaining. That part I'm going to cover quickly, and later on we will jump to other. Okay, fine. So these are the things which you might be know these things. Okay, this is autonomous vehicle made by driverless vehicle made by the Google. Okay, Vio, and then this is Asimo. This is a humanoid, first humanoid developed by the Honda. And then this is the drone delivery, package delivery by the drones. This is also very good example of the UAV, and the complete workflow can be made in the MATLAB simulating well. Okay, so these three examples, very good examples where the AI we have used the complete to make this system fully autonomous. We are using the AI technologies. Okay, these are the such very small examples. Okay, so you maybe work on that. And these are the some mega trends where we can find out in automotive driving, AI, data analytics, electrifications, virtual vehicle simulations, means that the software driven vehicle, advanced processors, FPG and other things. Okay, so these are the some mega trends where the different workflow we can use the MathWorks product, MATLAB simulating to make these mega trends from the idea to the production level. Okay, and as I told earlier that in the AI, we have a complete workflow starting from the data preparations, then pre-processing, then modeling, then training, then deployment. This complete workflow is we can do with the MATLAB. Okay, so these are my agenda. Some of the agenda I have covered yesterday. Okay, yes, this is the introduction to machine learning, then iris flower classifications, predicting fuel economy. That part I will cover, and then we have a deep learning. That where I stop today, then same thing we will continue with tomorrow as well. So image classification using the pre-trained models, then transform learning model, and summary of question answers. Okay, so let us begin. Uh, let us begin the today sessions. So everybody just see that this image is what the image is saying. The people with no idea, right hand side and left hand side, two images are there. I have two meaningful images are there. I have clubbed together, okay, to make my perspective.
ಎಲ್ಲರೂ ಮುಳ್ಳೆ ಮಾತಾಡ್ತೀವಿ ಹೋದ ಚೆಕ್ ಕರ್ನು
Okay, the people with the no idea about the AI take over the world and the neural network to just classify the
difficult আছে
to classify the simple neural network. It is not easy task. Okay, to classify the simple image, and my model is predicting wrong information here, whether it is a cat and showing it is a dog. Okay, so it's not easy way we can say that the AI will take our world like that. So we have to work on it very hard and make my model train correctly, so that the good AI application can be made. Okay, so of course you have Wikipedia definitions is there. So capability of machine to intimate the intelligent human behavior. The question is arises whether exceed the human capability or the match. So this is exceed or match. So this is the 2 point is come here. So whether the capability of machine to match the human intelligence or exceed that. So if we train the model more, then we maybe exceed our model, maybe human process the human intelligence also. Okay, it might be possible. Okay, sometimes it's look funny, but sometimes it is a time that our machines maybe work equivalent to the human, or sometimes maybe exceed. This is all about the artificial intelligence. That's all. Okay, this is all about whether it in the form of data, whether it in form of the audio and all the things. Then what is all about the artificial intelligence today? So by training the machine to learn the desired behavior. So the train the model, whether everything with chat GPT is there or large language model system is there, where the prompt response you are getting after enter something. Okay. So NLP is there, natural language processing, and so many things where we are working. It is a part of artificial intelligence. Okay. So the training a machine, training the machine means then we have a desired data sets. Okay, and you have a good processor and you have a strong storing machine. These three things is required. Training a machine, if I have written here training a machine, if you go through that, I have written here training a machine. What does it mean? This is the important word here in these definitions. Okay, so training a machines, you require the storage of the data. Okay, because you have a very long data sets. Okay, storing, of course, after the storing you require the process. So you have required the good processors. So you have to require the GPUs. Okay, maybe the required workstation type of the computers where the model will train. Some if you working on the biomedical images, the one image size will be around 1 GB, 2 GB, 3 GB like that. Sometimes maybe the 20 GBs. Okay, on that you have to work. If you have 100, that's such a huge images, then how you'll work? That is a challenge in front of us. So artificial intelligence is all about the training the machines to learn the desired behavior. Okay, and today it is a possible because you have a good processors available, you have a good storing capabilities of the machines, and of course the different I would say that the due to the GPUs you can train very easily in the within the last period of the time. So now see here, traditionally how we are doing the program, this thing I already explained yesterday also. The data program is there and output is there. And similarly, machine learning, you have input output both and you can program it. Then after that I have explained artificial machine and deep. These both are the subset of the artificial intelligence in learning. And of course deep learning is a subset of the machine learning when the data set is large, where the mathematical equation cannot be made. Okay, so where the deep learning can be used. Okay, it will learn from the data without pre-defined the features using the neural networks. These are the things. These things I already explained yesterday. The similarly, same concept can be applied for the same concept can be applied for the machine learning and deep learning both. Okay. First thing is that you have to acquire the data. Okay, you have to acquire the data first. So technical computing workflow is nothing but it tells that how MATLAB will help to follow all those steps. So first we acquire the data. Data may become in the form of files. Data may become in the form of like web services or the your database, or data may become from the hardwares or sensors. Okay, like your image you are getting. So from the webcam, USB cam you are getting, or cameras you are getting the images like that. So this is a low cost hardwares, through that you are accessing the data. Once you have a data with you, the next step would be the analyzing part. Okay, and exploring and making a prototype. In this case, you have a multiple options within the MATLAB, whether your data is a audio or video. So you have a video processing, computer vision, you have an image, then image processing, then you have a biological data, or you have a text data, then text analysis, signal and audio signals are there, then you have to audio processing or signal processing. If you have to apply the statistics and machine learning, then you have to machine learning applications. Once you selected the applications, and you have make a prototype, then next step is the deployment sharing part. With a value addition, you can put a value addition to your work here. So you can deploy under some HPCC or some web services, or you can make on some devices, okay, or you can make a report also. Okay, so this is a third step. Under the third step, so these steps cannot be achieved in the single line. You have to work multiple steps to achieve this. Okay, so you require one platform to make this multiple tasks in automated way. So that platform is is a MATLAB. Okay, that's all. So this is called as a technical computing workflow, how the machine learning application or any application will work inside the MATLAB. Okay. Now, after that, what is the machine learning I have talked about yesterday also. So we have to train our model correctly. Otherwise, this is the one chat. If all your friends jump from the bridge, would you follow them? The machine learning algorithm tells us yes. Okay, but in actual reality, it is there. Of course not. Okay, of course not is not a fact. That it means that we have to train the model correctly so that the machine learning algorithm must be aligned with the humans expectations. Okay, so ethics. So now in the right hand side image is tell us that about that this is your machine learning system. Until unless you do not take the right answer, if you get the answer wrong, then you have to pile up again to get the right, pile up your data again to get the desired results. Okay, so this is all about the machine learning. As I told you, the machine learning has a multiple applications. Okay, so these are the things are there. Machine learning we can use the anywhere in CS, aero defense, industrial automations, automobile, energy, finance. The prediction is a very inherent task. Okay, so machine learning is everywhere. We can say that where the machine learning can be applied. These are the area where the machine learning can be applied. Okay, and this part is already covered yesterday. Supervised learning. Under the supervised, I have covered the regression analysis whether you have an input output data both. Okay, so now today we jump to the classification part. Okay, fine. Under the classification, we will see that for the every machine learning applications, these are the steps. First, to access and explore the data, text file, spreadsheet, database, binary data feed, like that. Then after that, on the data type, we have to put the pre-processing data like missing data, outliners, time alignments, merging of the data. That part can be done. Then after that, feature engineering. It means that on the domain specific task is required after the pre-processing of your data. Like image is there, the image related or signals or audio or video or text, like that. Once the feature engineering task is over, then you have to train your model. Okay, now pre-processing and feature selection are over, then you have to train your model. The training a model is the next task. We can use our machine learning app directly, which I have shown you yesterday, or you can go through the step by this one programmatical manner. Then after that, you can, after the model is trained, then the deployment part or code generation part is there. Okay, so you have to automate the parameter to get the maximum desired results. Okay, like that. So this is called as a, and MATLAB support entire workflow of the machine learning. These are the symbols. These are the tribes where you can use it. You can save your task here in the, under the tribe section. Okay. Now this is a setup, workshop setup. Generally, I share the things. You can use the MATLAB drive. Okay. Now under the statistics and machine learning, you have a 157 shipping examples are available and 230 functions are available. So you can learn through the shipping examples or you can learn through the function also. Okay, so we have to explore this 157 examples. we can go depth in the machine learning and deep learning. So I request all to go through that. Okay, all these shipping examples, these are very useful. Now, to complete this task, you require certain products or toolboxes. So here highlighted is the toolboxes. We require the computer vision, deep learning. Then we require the statistics, machine learning toolbox. Again, we require the reinforcement learning toolbox, like that. Let us start with the iris flower classification. I have chosen here data set iris. Okay, so this is a well-known data set. I think most of the academics or research, they have used this data set to go for the classifications. Till now, any challenges, participants? So we will start with the iris flower classification. Okay, iris botanists, they have done certain experiment on the dimensions of the three types of flower of the versicolor, setosa, and virginica. Okay, and they have taken the sepal and petal length. For the sepal length and petal length of versicolor, sepal length and petal length of the setosa, sepal length and petal length of the virginica. Okay, they have taken the 50-50 samples. 50 samples for the versicolor, 50 sample for the setosa, 50 sample for the virginica. Okay, so this is the way. Now we have to identify if I enter any value in the 151 entry, then which one is the our which one is the flower. Okay, so first of all we have to load the data, then explore the data analysis part, like I think already I have explained in the regression analysis. Load the data in the two way. Either we can go through the workspace way, or either we can directly upload into the app. Okay. So load the data first, and the second one, the data analysis. After loading the data, you have to perform the data analysis, like a scatter plot. What is the mean value? What is the maximum value of my data set? What is the minimum value of my data set? What is the mode value? Okay, and then that part we can perform with the help of scatter plot, with the help of notch plot, like that. So we visualize it. We can visualize my data. Okay, so after that part is done, then we have to train the model interactively. Okay, so the training part, and after that, after the training, we get the trained model, and on the new data set we can test it. So this is the complete workflow of the that part. Fine. So let us start. So this I have to start with that. So this is a quickly I will go through the my file, and then I will explain you from there. I quickly save it, copy it, and I go to the my MATLAB, where my MATLAB is open. Okay, there is a MATLAB account. Okay, it's already there, I think. Then the path is added. Once path is added, now what we can do, I can start with the iris classification way. Okay, so this is my MLX file, iris flower set. Okay, I have taken this data from UCM machine learning respiratory. Okay, and it's also very popular. You also get it if you search on the Google. The data set will be available. Other way also, the .NET file data is also saved in my MATLAB also. So you have to just pass a command load arrays, load space arrays data. So you will get the workspace also. Okay, so this is the type of flower. So what can I do? First start with the clear and CLC. So I just pass a command clear and CLC and load the fisheries IDs. So this command you have to pass. If you are doing along with me, so you have to just pass these commands. Okay, along with me, you are also able to parallelly you can do. Once you pass this command load space fisher IDs, then what happen? Okay, so my folder is run. So I have uses the load space fisher IDs. Now, after that, you may find out two types of the variables, means and species. Okay, let us visualize it. What is there inside this folder or variable? Okay, under the means, you find out the 150 entries and 4 columns are there. These are the dimensions of the sepal length, petal length, and petal width and sepal length, like that. Okay, so there is no heading was there. If you go to the species, another variable, whether you can find out setosa, it scores up to the 150. Okay, total 150 versicolor. Now it is a VER means versicolor. Now VIR means virginica. Okay, it will go still 150 here. Okay, so these are the my database. These are my work. These are my experimental data. Okay, fine. Any problem? Anyone? Okay, fine. So this is my data sets which I have explained you. Now the data analysis part. Now first of all, because here my data set is the not a continuous, it is a random. Okay, so best visualization tool will be is a scatter plot. Okay, so GS is scatter plot. I am going to plot it for the mesh. For the mesh first row, second row, and the species RGB in color. So sepal length and sepal width. First we plot with the sepal length and the sepal width. Okay, that part I'm going to cover. Okay, once I run this, so this is the visualizations of my data set. The setosa is here, versicolor is here, and virginica is here. Okay, so what happened? So from this diagram, what you understood from this visualization tool, scatter plot, what is your observation? The observation is the setosa is separately. Okay, their dimensions are easily identified because it is totally separated. It is not overlapping with the other flowers. Okay, but versicolor and virginica both are overlapping with each other. It means my model have a challenge to distinguish between the versicolor and virginica. Okay, but setosa has a no problem because it can be easily identified and it will be easily segregated from the all the flower dimensions. Okay, so this is the information I'm getting from the scatter plot. So this is a one type of data visualization. Now after that, if you compare with the others also, let us understand the maximum value or mean value of my data sets. So I have used here box plot. Okay, I'm using the visualization tool as a box plot. So box plot will give you the maximum value, medium value, and mean value as well. Okay, so I have plotted here setosa, sepal length, and petal length sepal length and petal length for the this one. Okay, so that part is over. So now you see that petal length is larger and sepal length is smaller. Okay, for the any flower, the petal length is larger and the sepal length is smaller. Now similarly, if you plot for the others, in the box plot, if you plot all the flowers in the one place, like Setosa, versicolor and virginica, you may observe here Setosa flower size is very less. Similarly, versicolor and virginica size is little bit larger, and this red color is tell about the mean value. Okay, this red color is called about the mean value. Okay.
Excuse me, sir. Screen is
Yes.
not visible to me, sir.
Madam, are you able to see this screen, MATLAB screen?
No, sir. No, sir.
Sir, it is visible, sir.
For me only it is not visible, I think.
Okay, I again share it. I will again share it.
It is fully visible.
I will share again. Now, ma'am,
Yes, sir. Yes. Now visible, yes, sir.
so these are the sepal length, petal length, sepal width. Okay, so these are the things we can do. Similarly, on my data set, I'm also interested see what is the distribution of my mean value, median value, like that. Okay, so I have plotted here petal length with all the types of flowers. Okay, all the types of flowers. So you see that in this visualization tool, Setosa, versicolor and virginica with the petal length. So petal length I have plotted here. Then after that we require the notch plot. Notch plot will tell us okay. So this is our notch plot where I've just taken the sepal width figure. Box plot, I have used this function here, box plot. Similarly, okay, so this is my notch plot. Fine. So now what is the next? Similarly, I can make a for the petal. Here is a sepal. This is for the sepal length, sepal width, and this is for the petal width. This is the two way I can do that. Okay, so this is my data visualization of my these data sets. Okay, so basically the data you have some statistics part must be come over here. So to get to know its maximum mean value, data distribution, whether it is a uniformly distributed or whether it is a that type of the analysis is needed in the AI. Okay, once this part is done, once this part is over, now we can switch to the now switch to the combination, because here you may find out. So my response predictors and response. Okay, now classification is in the different folder. Okay, so what I do, I have to merge my data set. So I have used sepal length, sepal width, petal length, and petal width with 1, 2, 3, 4 column. And mace is the, and last, at the last I have make a one table, feature table, that is a one object, or and then I use the table command over here and write it down: sepal length, sepal width, petal length, and petal width, and last column would be species. That's all. Okay, so this is the way you can do sepal length, sepal width, petal width, and species. That's all. So this is the merging of my two folder by this command. Okay, by this command I'm merging my data sets. Now here, after that, once your table is ready, you will start with the app part. Okay, you will start with the app part. So you simply go to the app. Under the app, you go to the machine learning and deep learning part and click on the classification learner app. Once you click on the classification learner app, so this type of the interface will be open. I have taken the here screenshot. This is in the right hand side, you have a data set. Side you have a validation. Okay, so similarly this is open over here. The classification learner app is open now. Yes, everyone, are you able to see this screen now? Yes.
Yes, sir, it is visible.
Okay. So again, you go to the new session. As I have already put my table in the workspace. Regression I have explained through the file. Okay. Now through the workspace, I have to do the classification learner. So you have both the idea how to work with the file and how to work with the workspace. So today I'm taking the workspace way. So just I have click on the workspace for my new session data to learn the data. Need the data. So this is the interface will be open when you import it to the workspace. Okay. Now in this side you have a data set on the left hand side, on the right hand side validation and test. Okay, so left hand side you have to set your variable. So just drop down menu, you have a if length, maze, sepal length, like that. Here you require the table. So table is required. So I have to again, because it's not correctly come here. So I have to import it. Sometime it happened. So I go to the workspace, put the data. Now I select again, properly run or not. Let us see. Okay, I will again come back to my MATLAB, and which command I am going to see whether my variables are created or not. So again I will go to the, okay, I have not run yet. That's why it is not coming. That's why here whose command come into the picture. Here the table is not formed yet. Okay, and I have already opened my file. So I have not run this folder. I have not run this folder. Okay, I have explained you, but I have not run yet. Okay, so I have to run this. Yeah. So now, yes, now it is a run. Now you have now again go back. Now want to see that what the different variables are there. Go to the whose or who, whatever you want. here I require this feature table, which now I have created just now in the my previous explanations. So this is the thing I require. Now again, so because I'm not able to run that, that's why it's not come. Now it will be available. Just close this. Now again, go to the from the workspace, click on the workspace. That variable is available. Now it will show. Now see that the value will be shown here. Now see here. Yeah, these things I require. So feature table I am interested. 150 entries are there. 5 columns are there. So just make an entry of the feature table. So here you have a sepal length, sepal width, petal length, petal width. Last one is a species where you have to identify with these dimensions. Okay. Here I have a cross validations I have selected, and folds are the 5. Because data set is a very small, so I avoided the test part. You can do if your data set is large. And just click on the start the session. Once you click on the start the session, okay, the similar to the classification, similar to the regression, classification is also similar one. Okay, so here you have all the models, decision tree, discriminant analysis, logistic regression. Okay, like that. Support vector like that. So these are the models are available, just similar to that. And here you have a confusion matrix, scatter plot, ROC curve like that. Okay, so I will click on the quick to train all. Okay, to save my time. And then after that, I will train selected. I will train. Okay, so it will take some model, at least 10, 12 model, and it will start modeling, it will start training to our model. I have already uploaded my data sets. After visualization, it will be take some time. Okay, training has been begun. As this is a classification, so we are look for the accuracy. Okay, we look for the accuracy, and regression we look for the RMSE value. Some other parameter is also there. So I will compare with the one, with the worst model and with the best model. Okay, the accuracy of whose model is an accuracy with the worst model. So I have run all my effective quick to train all model, and now see which is one the showing the worst performance. One is a 66.7. Okay, so the 66.7 is the worst model, that which is the Cores KNN. So just click. After clicking, you have a accuracy, total cost, if it's error rate, prediction, all these things are here. Okay, you may find out all the details of the training results will be mentioned over here. Okay, now go to the scatter. If you go through the scatter plot, just click on the scatter plot. Here you say that the setosa is clearly separable, but the versicolor and virginica is overlapping with each other, and this cross sign identify the cross prediction. Okay, wrong prediction. Now, after that, after the scatter plot, just click on the confusion matrix. So it will give you the confusion matrix of the selected model, which is the KNN. So here you see that 49 times my model is predicted. This diagonal is a diagonal in the confusion matrix. I think how to visualize the confusion matrix, let us understand. Okay, so in the diagonally, the elements which are available is the corrected value. Okay, perfect predicted value. So this is the correctly predicted, but other than the diagonal value is the wrong value. So here Setosa first time 49 is corrected. Okay, 49 times my model predicted correctly. Only one time model predicted wrong. In place of Setosa, he suggests that it is a which one? Versicolor. Okay, so this is for the Setosa. Again convert the second diagonal element color. So 47 type my model predicted correctly, and 3 times inserted of the versicolor he predicted Virginica. Okay, so this is the another information I am getting. Then at the end you have a Virginica. So corrected value only 4 times. 46 times it is a wrong value predicted by my model. Okay, so this is the confusion matrix of the my worst model. I have selected KNN after training. Now look for the higher accurate model. So which one is a higher accurate model? 95, 96, 96.7. So 96.7. This is the best model. Just click on it. If you click on it, you may find out their training results. All the things are available. Now click on the confusion matrix. If you click on the confusion matrix, it's perfectly identified, which is also visualized in the graph. Now 48 times correctly identify versicolor, only 2 times wrong. Okay, now what about the others? Virginica 47 times predicted correctly, only 3 times they have predicted the wrong. Okay, so this is about my confusion matrix of the worst model and best model. If you want to optimize, then you have an option here, optimizer. Okay, so this is the ROC curve. Similarly, you can lay out result table. If you click on the result table, you can compare with the other trained model. Okay, so here I have trained the model, selected model here, trained, their accuracy is come over here, total cost is also come here. If you click on the result table, okay, so like that you can do your own analysis. If I click over here and export the model, then it will be exported the outside. Fine. So this is the our trained model, and now jump to the, here you have an option YFit scores trained model prediction T. Okay, so if you have a T folder name, test folder name, then you can predict with the new data. Okay, I will tell you on this part when I select this one, decision tree method. Okay, so this is the way you can use this classification learner app for the AI applications for your own data set wall. Okay, any doubt, any challenges? Similarly, we will start with this one, decision tree. We will take the decision tree as a standard algorithm, okay, for my own data set, and see that how decision tree will work in that case. I think all of you know that at the you have a tree like We have a two predictor. Okay, top node and the start node. So x1 and h2, its certain condition will satisfy, then it become the another thing. Other it will not satisfy, then again new condition will be imposed, and further it will be new predictors. Okay, like that. This is called as a decision tree mechanism. So similarly, I have load the value. Similar to that, load Fisher iris is already loaded. Now after that, tabulate the form. Fine. So now tabular format में Setosa, versicolor and Virginica is a 50-50 count and well balanced data set. This is called as a well balanced data set, 33.33, 33.33, 33.33. Then you have a G plot matrix, maze species. So plot matrix can be done, geoplot matrix for all my variables. Okay, fine. So now see here, the same thing I can apply here also. So decision tree I'm using without using app. So just click here. The same data analysis I'm performing. Then after that, I've used this model class tree, fit C tree. This I have used this train model as a classification. Okay, and their properties is also mentioned here. Category, on which category you are using. Now after that, view the class tree. So you can view your class tree also. What is the condition value? Then when in which condition it becomes the Setosa. Then again further new condition. Then again class, like that. Okay, if you want to visualize it, so just click over here. Class tree mode and graph. You want to visualize. Now see here. This is your graph. The train model, how it will behave. Under the decision tree, one algorithm I have chosen, and on that I have applied the things. Okay, Setosa. Then you have a this is the condition. When satisfied, it becomes Setosa. If it doesn't satisfy this condition, again new condition will be imposed. Under the new condition, it's become Virginica, or other way, it's become to the jump to the new condition. Now it's become Virginica. Then again new condition. Now it becomes the next thing. Okay, so this is the classification tree viewer. Now come to the now you can test with the new data. Let us suppose you can tell me if you have anybody can run their own PC. If you are using parallelly, if you are doing, so give me the any column value. Okay, so I can pass here and then see that whether it is a correctly identify or not. Okay, so just open the your value, just like a species, petal, train model is also I imported. Now go to the mesh. Go to the mesh. Now you have a data here. So anyone can note it down: 49, 3, 1.4, and 0.2, and see that whether it is a correctly identifying or not. I have chosen the second column. Just remember. So 49, 3. So just pass this value. 49 and 3. So 49, 4.9. No, okay, 49, 4.9 may be there. So 4.9, 3. Second value 4.9, 3, 1.4 and 0.2. 1.4 and 0.2. 3, 1.4 and 0.3. Okay, so this is the I have taken the second column data. Okay, and I have trained the model over here. I have trained the model here. Okay, so this is the thing I have done. Now what can I do? I can simply pass a value. Okay, I have not run this, so that's why has not come. Fine. So now run this. Now it is going the Setosa. Now I go to the my maze, not maze. Which one I have to go? Sepal. Yeah. Sepal, petal, species. I go to the species. Now see that second one is the Setosa. Just visualize it. This is the Setosa. Okay. So it means that my model is perfectly fine with that desired accuracy. Okay. Now see that how much accuracy is there. What is the quality of my tree? So this is the error button. So 0.02. So you have this is my quality. It should be near to the 0 value. Okay. So using the loss, I have identified the loss of the class tree. Now after that, once I classify the class tree, then improve how predictive accuracy, the CVR tree. I just run this. Now you can see that X1, X2, X3, X4 predictors CV tree, and with that value, and you have a k-fold losses of the CV tree is also mentioned. The CV losses you can also find out by the programmatical way. Okay. So any challenges participants to understand this classification by the two method I have explained, one through the one specific model, one through the app. Okay. So if you have any problem, please ask. Now after that I will switch to the deep learning. Participants, any challenges?
No, sir.
Sinde. Okay. Okay, fine. Okay, it's better. You have no challenges. So I will stop here. Classification learner app. Okay, because the work is over. There is a 125 people has joined. Okay, now see here. I will switch to the next part. So I will again stop sharing and then I will share it again. So, because some of them is not able to see my screen. Yes, screen is visible now. So regression is over. Now let us start.
Yes, visible.
Next thing is a deep learning. Okay. So theory part, you already know that these are the digit identifications, means data sets. Then you have to identify the objects like whether it is a whether it's a four-wheeler, two-wheeler, or whether it's a tail head, and then whether it's a demarcation of the road, whether pedestrians, whether it's a signals. Okay. So these are the things. So when such type of applications, when you are working, then you require the deep learning. Okay, when large data sets are there and the mathematical. So deep learning is a type of supervised learning, which is model to perform classification tasks directly from the image, text, and sound. Okay, deep actual meaning is the number of layers in your system. Okay, sometimes the machine learning cannot be the results on the image has been limited, but the deep learning in that situation, when your data set is image, text, or sound, then deep learning is a very good options for you. Okay, so deep learning usually implemented with the neural network. I can say that artificial neural network, of course, not the human neural network, but it's just similar to that way. Okay, so just take the key. The deep means has more number of layers. The more deeper your network, the more prediction will be correct. Okay, that is a part in the deep learning. Now, why deep learning is a more popular? Those who are teaching this subject, maybe the faculty members may be there, okay, or some PhD scholars, those who are going to work on this area. This is the answer where the why deep learning is nowadays popular. This is the this dash dash. This is the dash dash line. This line, this line, this line is about the human error. This is the human error line. Human error line. Okay. So this human error, earlier what happened? My machine learning model, my train model giving the around 30% error. Okay. Which is the above the 7.5. Is the generally human error. It is above the human error. Okay, but as the time passes, you have a more data set, then the machine learning will be also reducing their error. Okay, suddenly after the 2012 onwards, okay, what happened? The deep learning model error accuracy will reduce to the human error also. It crosses the human error and below the errorless accuracy. Okay, so this much it will go. That's why it is become the more popular. Okay, so this is the, I would say that the main reason behind that, they are competing with the human error. Now see here, deep learning succeed by because you have a very level public data sets are available. Progress in GPUs for acceleration is available. World-class models and connected community. So you have a, these are the things. We have a much data sets, public data sets are available. You can accelerate your work on the GPU, that is also available. Okay, and you have a already pre-trained model to save your time, like AlexNet, you have GoogleNet, you have, okay, so ResNet you have, VGG16 you have. So like that the things are there, so you can do such a things in the this model. Okay, so due to that the deep learning is more versatile in the nature. And now you have lots of examples. If I click here, object detections, you can use the deep learning model for the object detections. You can use for the image classifications, the speech recognitions, like that. There are various applications are there. Okay. Now, this application, how to start with these applications? This is the next part. So you have a MATLAB Simulink. So let us understand the deep learning workflow. The simple it is as it is. The files, database, data augmentation. You require first data through the database, sensors or files. Then you have a data augmentations, labeling, because deep learning will work on the labeled data. Then you have a hyper tuning. Then the network visualizations. Let us see how the each layer are training, okay, or learning. Then you can deploy on the desktop app to make some model, or you can deploy on the some interface to generate the C code or embedded devices. So integrate model with the systems that parties can be done. Okay, so major problem whenever anyone who work on this field, they have a major challenge with the labeling of the data. Okay, this is the major challenge. Okay, labeling of the deep learning is a repetitive, tedious and time consuming, but it is a necessary. Okay, so you have three types of data: image, signal, numeric and text. Okay, all these are the area of the deep learning. So today we mostly focus on the images. Okay, so you have these apps: image labeler app, video labeler app and audio labeler app. With this you can label your image, video and audio. Okay, these are the links: image labeler, video labeler. You maybe explore later on. Okay, so how these leveler apps are work in your data sets under your like that. Okay, for the explanations, so if I quickly jump to the MATLAB and see that how these are the work. Yeah, so if I open some of the app here, so here you have a app, Deep Network Designer app here. This app I'm talking about. There is some changes are there in 2014 A version. Okay, there is a major changes in Deep Network Designer app. Whether just I open it and then I will tell you. Similarly, you have other apps also. Here you find out all the list of the app. Okay, so leveler apps. Yeah, so it is open now. Okay, here you can do this Deep Network Designer app. So I will come on that part. You have to separately, you have to download all these models. Okay, so blank model, workspace from the PyTorch also you can import, from the TensorFlow also you can import into the MATLAB. Okay, then you have a SqueezeNet, GoogleNet. This triangle single says that you have not downloaded this model in your MATLAB. This triangle is showing like this. Okay, so we have to download it separately. Okay, so these all about the pre-trained models are available. This is called as a Deep Network Designer app. Through this app, you can design your own deep network. Okay, for your own applications. So everyone, this is the way. This is the latest one. This model is the latest one. Okay, so here you can directly import out through the PyTorch and other things. By default, GoogleNet will be already there within your MATLAB, but others just like a ResNet and other models, just like AlexNet, it is not there. You have to download it from the from this VGG is not available directly. You have to install it. So this is there. So I will tell you how to do this part. Okay, so other apps are available. So here you may find out leveler apps. Okay, so here you may find out all the things. Now jump to the PPT again. So if you see here, so this is the leveling of segmentation of the road with the pedestrians or with the other cars, with the tail light, with the sign that can be done. Okay, this is the videos are there. You can easily find out. So then now come to the our network part. So AlexNet, you have AlexNet, SerialNet, RecurrentNet, RCNN, LSTM. Okay, so these are the a single input, single output, multiple input, multiple output, like that GAN model or the DQN, LSTM. So these are the many network architectures are available in the deep learning. These are the many network architectures, and which architecture will work for your data set, that we have to identify, and we have to study for that. Okay, so there are various combination of the different network architecture we have explored. Every network, the convolution neural network is a very popular. So really popular. So it generally works for the images. Okay, so here is a multiple layers. There is an input layer and there is an output layer, and in between that, middle layers are there. Okay, and the last one is a fully connected layer. We can classify or classify layer as the last layer, and that can be classified the your objects. So each layer are interconnected and they have trained to predict some features like edges, color, okay, object, like that. So these are the work for the respective layers. Like first layer have to identify the edges, next layer will be identify the shape, and next to next layer will be identify the objects. Okay, so this is the way this convolution neural network will work, and at the end you have to classify and then will tell you the flower. That's all. So how does CNN work? So this is the way CNN will perform the future identification and classification of image, text, sound, video. As I already told you, the input layer and output layer, in between that hidden layers are there, and each layer are interconnected to each other. Okay, so like that. So these are the 4 lines of code you can perform the deep learning. That's all. Okay, so net is equal to LXNet you have to do, and the IMD you have to pass this, load the any image. Okay, and because LXNet is made for the 227 by 227 size, you have to resize it and use the function classify. That's all. The answer will be pick up. Okay, so let us try deep learning with the 4 lines of the code. Okay, so I will jump to the MATLAB again. Okay, so first of all, let us see that whether the LXNet is downloaded or not. So I will pass this command. Deep Network Designer app. Just a minute. Oh yes. Okay, so I'm just hiding. So this is the older version. Those who are working before the 2004 on the Deep Network Designer app, so you have to, if you want to access the previous version of the Deep Network Designer app, then you have to pass this command. Okay, this command, inverted comma minus v1. Okay, if you want to use the newer version, then you have to simply pass a command Deep Network Designer, or simply go to the app, go to the machine learning deep learning section gallery, and where you can select the Deep Network Designer app. That app is a newer version. Okay, I'm using the 24A version of MATLAB. Okay, so Deep Network Designer, the previous version I have required, then I have to pass additional this syntax and just enter it. Once you enter, the similar to the newer version will be open. Yeah, this is visible now. I quickly summarize. So this is the older version. Now I have to see that whether the my LXNet is there or not. Okay, that can also be checked. GoogleNet is there, and ResNet is also there. LXNet is a no, it is not there. Okay, so I have to install it. So I have to click over here. So let us see that part I will do later on. So first of all, I will run the program first. Okay, fine. So let us start with the program first, and then after that we will do that exercise. Okay, so just allow me. Okay, so just allow me to open my pre-trained model. Okay, this is my pre-trained model. So I have already created this folder for you. Okay, so this is my folder which I have kept here under the code or under the FDP. So this is my model. Okay, so I've just copied the destination, Control C, and then I will come here and put a Control V and enter, and then I will go to the DL where my codes are there. Yeah, this one. Just select this one and right click and add to the path. That's all. So it become in your current folder, and here I have a first I want to tell you which is a LXNet. Okay, so better to start with the GoogleNet. GoogleNet is a very large model. Okay, so let us start with the LXNet first, and you will understand. step-by-step manner. If you have a laptop with you, or you have downloaded to open the MLX file, and along with me try to do that. Okay, so you will try to learn so many things from here itself. Okay, so just click here, net is equal to LXNet. So I'm uploading my neural network, deep neural network, which is a pre-trained, and just I'm clicking here. Okay, so it will give me the error. Just see that. Why it's giving me the error? Because LXNet is not, I have not downloaded yet. Let us see that. Of course, it gave me the error. Yeah, it's absolutely fine. What is the saying that error using the LXNet? LXNet is not available. Okay, I was saying that go to the add-on option and try to download it. Okay, so I already told you here that here this symbol is there, and due to that I'm not able to download it. Okay, but by default Google Net is there. So Google Net, if I open, then it will work. So let us because LXNet is a very small model, so you have a depth is 8 only and 227 like this. Let us try to install it first. So click here, then click here. So I intentionally have not downloaded this one to show you this part, so you also understand how to download the different pre-trained models. So this is the only agenda. It not take that much time. It will take very less time. Hope so. So you also get to know how to add the different deep learning pre-trained models. So first we go for the LXNet. Now after that we will go for the Google Net. Okay, it's taking some time. So meanwhile, we'll jump to the other part. Once this model is trained, so we will start that part also, LXNet. So meanwhile, we'll start with the Google Net. Okay, it's taking a time. Once the downloading is over, then we'll come to the LXNet also. So Google Net is already loaded. Okay, so we will start with the Google Net. Let us see. So meanwhile, just clear the CLC, pass a command CLC, then clear. All. Is making sense? Anyone? This demonstration making any sense to you? So multiple things I'm at a time I'm working. So okay, fine. Similar way you can okay, it's now clear. Now pass a command, clear. So your workspace will be get clear. Go to the Google Net. Now you may search on the Google Net. What is the it for Google Net has been trained over the millions of image. Okay, Google Net is a millions of image. Okay, of the 1000 object categories. Try to understand: keyboard, coffee, mug, pencil, many animals, tiger, like that. They have taken the thousand of category and taken the every category. A sum is the millions. Okay, on that the network has learned rich features representative for the wide range of the images. So this is the we can leverage this train model which is available. So here I have prepared step the what is the step? Step one is the load the pre-trained model. Okay, so here I have make the Google Net, Squeeze Net, Press Net, Press 50. That's all the train models I have mentioned over here. So I will go with the Google Net because Google Net is already loaded. If I go through the AlexNet, so AlexNet is taking us some time to upload it. So better to start with the this one. Fine. So first we know the Google Net and pass a command who. Let us see. So what is the informations we are receiving? So which variable? So net. So whose? So you may find out how much bytes are there. Net is becoming Google Net is stored in the net name variable. Now when you pass a command whose, now it will give you the its features. Okay. So it's 1 by 1 size and the byte is 296.4931. Okay. So design a network. So let us know what is the first size of my Google Net. So you have to pass a command input size net dot layer first and input size also. Okay, so if you pass a command like this, so you get to know what is the input size of my first layer. Okay, of my Google Net. So it's a 224.224.3 like that. Okay, fine, no issue. If you pass a command Google Net input size, similarly you have the other option also. You have a, if you clear this input size, then if you search name, mean, standard, median, maximum, normal, input size, data augmentation, normalization, you can search for the other option also. Okay, so you can search in input or whatever, normalization, like that. So if you want on the input size, so this is the input size of my Google Net. Now what are the different names? What are the, let us understand some different names, on which names or what are the class names are there. So display the class name up to the 150 105 I have mentioned, class name dot layers dot class layers. Okay, if you go through that, so these are the class names on which the model has been trained. Okay, just comic book, the revolver, and then you have a neck brace, drumstick, nail box. Okay, they have used these images to train this model. Vehicle, flat, pajama, broader, then harvester. Okay, then you have a hog, then you have a volcano, then you have a slug, window seat. Okay, joystick, and like that. On this type of the images, this Google Net image has been trained. Okay, so it just I have by this command you get to get the information about the my train model. Okay, so now let us start with the test. Let us test it, or you can do the same exercise which I have mentioned here. So what you can do, I have some test images also here. So first of all, test with the this read and resize the images. Okay, so I have downloaded certain images. So I will show you outside of the my this MATLAB. So outside of this, open the outside. Now see that test2.jpg image is what is all about, and then how they are predicting the correctly or not. So this is the image I have downloaded from the Google. Okay, so it's a lion or tiger, whatever. Now, so that is also in my current folder. So I just passed this command because the size of this image is very large. Test2 image. Okay, if you size it, so now see that if I see size of I, let us see here. The next part is the size. Okay, so now see that what is the size of my uploaded image. Just see that what is the size of my uploaded image. So this is a 290. It is a 290, 474 and 3 RGB. So 290 and 274. Yes, everyone able to understood how I am proceeding? But my Google Net is trained for this size of image. The Google train is made for the 224. Okay, so of course I have to resize to my train model size. Okay, so 220 and 474 will not work. 224 I have to make it. So by this command I get to know what is the size of my uploaded image. So now I have to make a image resize 1 to 2 figure like that. So it will be under the size has been reduced. Okay, now size has been reduced. Now you can use this function, label, scores and classify net cross eye and label it. Just pass this command so you can classify the image. So it's showing the lion, okay, which is absolutely correct. Now what is the percentage? So just see that. So percentage 99.9%, which is also correct. Okay, by the human eye also. And level of top level prediction that can also be predict. Okay, by this function. What is the prediction level? So top prediction line, because 99 is there is no other options are available. Okay, so this is the command we can do. The scores index they have taken randoms. Now what we can do? We can do with the how the pre-trained model work. We have to able to learn. Now change the figure. Change the figure. I have stored another image also here, and let us see that on this category how it works. Test image 3 is there. So just change the 2 to 3. Already 3 is there. So just test 2 to 3 and see that what is the difference. Just click here. Now see that image is okay. Now it is a tiger. Now this is a tiger image. Now see that what is the size of my image. Just run this program. So you see that the size is 1983 So I have to reduce this this image size to my 224 size. So how can I do that? By passing this command. So this size will be reduced. Now check the size of my image. Okay, now classify the image. So just see here whether they can correctly classify or not. The previous answer. So now it is also classifying perfectly fine. Tiger. So absolutely correct. It's a tiger image. And how much percentage is there? Let us identify it. Yeah, 72.9%. Okay. So yani it means that they have confused with this image, whether they are a tiger cube or something else. Okay. So let us see that on remaining percentage belongs to which category. Okay. So remaining on which category it's belong. So just see that. Just click here. Okay. So just see here the probability. Okay. They are confused with the tiger cat and tiger. Okay. This is a major confusion. Means it's like a tiger adult or tiger cube. Okay. So this is a confusion. So I have to train my model more and more. Okay, it may be possible that I have taken the image which is the photo generic image, or it is a some website I have taken, or software generated image like that. So this is also one chances that the accuracy has been reduced. Okay, so this is maybe the chance. Let us explore one more thing. Let us explore the last image which I have taken, test IMG. So just pass a test IMG, test IMG. Now see that what is in this case, and see the how the my model will behave. My train model will behave. This is the umbrella. It's look like, but this umbrella is a software generated image or human drawn image or original image. So that, let us see that on this such type of image how the my Google Net model will work. Okay, so I have just already 10. This is a 550 by 592. It means I have to reduce it to the 2 to 4. Let us reduce it because my train model is a size is 2 to 4. Okay, so let us train it. It's already reduced. Now classify with the help of classify the image. Classify command. Now once you type this, the parachute. Okay, just see that is confused over it is a parachute or umbrella. So let us see that whether the umbrella in prediction or not. Okay, fine. Change that 24.4% parachute. Parachute umbrella. So between the parachute and umbrella, my train model is confused because I have taken from the Flipkart. This image I have taken from the Flipkart, and generally on the Flipkart, images are the software generated. Okay, so this is the way you can use the class image, Google Net image to classify the images. Okay, so this is the one thing. Hope so all of you have understood this classification, how to classify this. Now jump to the next part, which is the last part of the today's session. So quickly jump to the PPT to explore the more. I have to share again, I think so, because no one is asking the questions whether they are listening me or not. This is also doubtful. Okay, so last part I will conclude here. Just a minute. Let me check. So I will.
Hello?
Yes, sir. Hello. Now the last part is this one. So with the help of Deep Network Designer app, so you can use these different types of layers. As I told you in AlexNet, how to use that, how to classify the images with the different images. Just now I have demonstrated. The similar way you can use the different layers like that. So I will tell you where you can do that. So I will start with the Deep Network Designer app. I will open the any blank model. Just click on the blank model. Okay. Now Deep Network open is open. Now here you can import your layers, different layers like this layer, then convolution 1D layer, then you can import a convolution 2D layer, you can connect here to here to here, you can change the property by double click, and here you can change the value, okay, and the 2 to 4 or whatever the size of the things are there, you can rearrange it, auto rearrange it, it will rearrange, okay. Then you have to analyze, then you have to click on the analyze. So this is the part where you can do, if you want to data or training, so this is the sections are there available for you, data or training, and where you can do a number of things of analysis, okay. So this is a part. Yes, everyone. So I will stop here, and tomorrow we will meet again. If you have any questions, then ask me. Yes, participants. Any problem? Any questions to understand this Deep Network Designer app? Hello? Anybody
They
there?
are not. They are not
Yes.
replying. I think participants are not replying, sir.
Any problem to understand this Deep Network Designer app? So this is the way.
Not till now. Not till now.
Okay, fine, fine. That's all.
Sir,
So this is the
can
way
you,
you can create your own network.
There's a question, sir. There's a question being asked.
sir, will you please expand the graphical user interfaces tools which are available in the deep learning network in MATLAB in tomorrow's session?
Graphical?
Yeah,
Which one, sir?
graphical user. So I think whether there are any single graphical user interfaces, just like in fuzzy logic, I have seen the fuzzy designer toolbox. So whether
This is
such
in front of you. This is a Deep Network Designer. Is a graphical representation, na? You
so
have
whether
a convolution neural network is here. This is a
tools are
convolution 2D neural network. So if you analyze this part, then this is the if you have you explored the Deep Network Designer app.
okay. So
This is the graphical representations. These are three layers are there. I have taken.
Mhm.
So you can analyze this. You can visualize this, and visualizing this is a visual screen is visual. You are able to see these layers?
Yeah, it's visible.
Yes, sir. This is the graphical representation.
Okay.
This is the graphical representation of these are the layers. Okay. These are the layers. So
Oh,
I can rearrange it here.
okay, yeah. So we can,
Yeah, you got the rearrange. You can make your own layers. Okay. So
yeah,
if you want to do that, then you have a batch normalizations layer. You can bring these layers over here. The fuzzy
Okay.
logic type, this is the things are there. Nowadays, fuzzy logics very
So
less in the soft computing. That is a part is there,
what simulating?
but
Can we run,
deep learning is a more dominating.
can we use the same modules towards simulating and have the simulations?
Yes.
Okay, so
Just
will
please
you
loudly speak.
explain those things in the tomorrow's class?
Which class you are working?
Tomorrow also we have a class.
Tomorrow you have
Yeah.
on this.
So
What the things you want?
will you
What are
please
the
explain the simulation process that could be done by using the deep learning toolboxes, using simulating?
simulation? Okay. On which application you are working?
Oh, basically, I'm a professor. I'm not
No,
working.
no, that's okay. You are the professor. I understood. You have
Uh,
raised the question to make an interaction. That's I know understood.
my
So
domain is DSP. Any domain will be fine.
okay, you want a deep learning model to the Simulink.
Yeah, sure.
Okay, that is also available. That can also be done.
Okay.
That part is also be done. So your train model will be imported to the Simulink, and then that part is also can be done.
Okay, please include that also in tomorrow's class. Okay, thank you.
Okay, so sir, you have worked with this GoogleNet and AlexNet this part, which I have shown here. Then I have another option, the transfer learning. So that part is remaining. Still, it is required 1 hour time. So I quickly cover it from here through the PPT.
Similarly, will you please share the slides to us?
Okay, okay.
Okay, thank you.
But the students are not okay. Fine. These are things. Edges are there. Now transfer learning approach. This is the way. This is a digit set, import a data set, then network design your network. Is it visible or not? I don't know. So then it is a train the model like per epoch how the error are minimizing.
So
That
there is a
the
query that will you share the PPTs?
because under the copyright issue, but whatever the things will shareable and then I will share with you. No issue.
Okay.
Okay, so this is a getting started transfer learning approach, and then this is a transfer learning. So this is the last part. So where you can change your any layer of the pre-trained model, and its value will be changes, and accordingly the your trained model is yours, and then accordingly you can change the characteristics and all those things. Please explore these things. This network designer of your area of the deep learning, it is there. I will share it to the mail. Just drop a mail. I'll share to you. Yeah. So just last video. Through the video, I was summarizing this part.
This video shows you how to use the Deep Network Designer app to perform video shows you how to use the Deep Network Designer app to perform transfer learning. Transfer learning is the process of adapting a pre-trained network to a new task. Fine-tuning a network using transfer learning is usually much faster and easier than training a network from scratch. To begin, load a dataset into the workspace. This example uses images of MathWorks merchandise in a folder called Merch Data. To perform transfer learning using Deep Network Designer, open the app by selecting it from the Apps gallery. Deep Network Designer provides several pre-trained networks for image classification problems. You can use any of these networks for transfer learning. For this example, choose SqueezeNet. When you import a network, Deep Network Designer displays a zoomed-out view of the network architecture. From this view, you can see the properties of the network. For example, SqueezeNet has 68 layers. Zoom in to take a closer look at the layers. Select a layer to view its properties. For example, you can see that the image in the
Mr. Sheikh, you have raised your hand. Is there any query?
127 pixels. To load the merge data into Deep Network Designer, select the Data tab. Click Import Data and then choose Import Image Data. In this dialog box, you can select your training data, set augmentation
Hello?
option.
I'm audible, sir?
First, select the unzipped merge
Yeah, you are
Hello?
audible. You can ask your question.
names of the
Yeah.
subfields.
Sir, I think from my point of view, so whatever you are deep learning, this one you are explained. So it is more understandable if you can apply this deep learning option or deep learning database systems to any engineering applications, either electrical, mechanical, or electronics or computers also. If any one application you can apply for any one application, if you can apply this deep learning database system, so it will be more understandable what I feel is.
Oh, yes, sir. This is the, yes, you are saying you're absolutely correct. Okay. If you applied any applications, so this is your applications, which I have shown you. This is the minced data sets I have, image processing. Okay. You have to identify the images, whether it may be used in the check balance and other thing, financial sector, whether this is the image is correct or not. Okay, so I'm working with the means data set. Okay, so where is it, this data sets I will show you. So this is the application. I will tell you which you are asking, the some application like electrical to find out the SOC or anything. So this is the example I bring in front of you today. Just a minute. Yeah. So this is my data sets I have. Okay. So I will open outside the MATLAB. And I will show you where is my data set. Fine. Let us go through this way. So if I go through where this data set is available, my PC, then sorry, my PC.
Sir,
Then
so you can take the example of SOC of battery, so that
SOC is the further thing, which is a not today discussion part. So just see here, go to the MATLAB, and then you go to the toolbox. Here I have stored my this. Go to the toolbox. Under the toolbox, go to the nets, where this my data set is stored, which I'll show you. You might be interested. NNNet, go to the NNNet. Under the NNNets, go to the NN demos. and here you may find out the data sets. Okay, this is the digit data sets which I have worked. This is the 0. So this is the all my data sets I have. Where I am, this is a minced. I've identified the zeros 1, 2, 3, 4, 5, 6. So this is my data set. Okay. So this is one type of application, no, sir? This is also one type of applications.
Yes, sir.
Now see here. This is 0. This is 1. And then you have to do 1000 images I have taken. 2, 2, 2, 2, 2, 2, like that. So total 10,000 image I have taken. So this is a 999 up to 9. 0 is starting from 0 and up to the 9. Okay, so this is one type of application which I'm trying to explain you. Okay, now problem is I have to make such a deep learning model. When I pass any digit, whether it's a handwritten, computer generated, anything, it have to correctly identify the digit, recognize the digit. Okay, this is my problem statement.
Nothing but it is the image or number. So it will recognize from the n number of data sets.
Yes. On the
So
image also.
Image.
That is true now. So this is one type of application I'm trying to explain to you.
Okay.
And for the SOC which you are asking is also available. You go to the documentation, you just search it. You will find out one application is there. On the DOC if you go, and the very good examples are there. And that they have used the ReLU layer to identify the remaining useful life of battery with the help of this ReLU layer, which is also part of the deep learning. If you go just search here, so that is also there. So this is the application I bring for today demonstration, sir. Similarly, merchandise classifications. So this is the merchandise. The different merchandise are there. So basically, I have worked with the images large. Okay, so whether which type of the merchandise is there. Okay, so my train model is correctly identify that part. Hope so I'm clear to you. Tomorrow we will see more thing about the deep network designer and other things. Okay, so these are the some basic part which I have covered. Tomorrow, let's possible to me, then I bring the network signaling and other things as well.
Sir,
Okay, thank you so much, sir.
Yes, ma'am. Yes, please.
Sir, I want some guidelines regarding robotic analysis in MATLAB.
Okay. Yes. Ask me.
How can I use MATLAB in robotic analysis, sir? Because this is the subject which is given to me, robotics, and I'm going to deliver it first time. So,
okay. So we have a very good, just type a DOC here. DOC.
Okay.
We part type a DOC, then documentation page will be open. And under that documentations, you go to the here robotics and autonomous system. Just click here on robotics and autonomous system.
Okay,
You
sir.
find out very good content available.
Okay,
The
sir.
raw navigation around automated driving system. Just go through the robotic system as you mentioned. Okay.
Okay, sir. Yes,
Now
sir.
you have a documentation also, and lots of examples are there. Getting it started, robot modeling, inverse kinematics, motion and path planning, robot simulation, collision detections, like that. These all are the
Okay, sir.
subjects. Okay, and just click
Yeah.
on the examples. If you click on the examples, then you may find out lots of things, path planning. Okay, so
Yes, sir.
just click on the 2D dynamics. Its script will be open here. Now you can make a constructor simple robot. So
Okay.
here you have a lots of options are available. Okay,
Yes, sir.
there the simple robots are available. If you want, then I conduct the session also in that.
Yes, sir. Thank you, sir.
Okay, here you have another options. So path flowing river, and then also I have a ready-made materials are also available. You drop a mail, then I will share with you. So
Yes, sir.
these are the path planning, and then all the things. I don't know what are the exact content you are going to deliver, but all the part maximum universities of India that contents are available. Maximum contents are available.
So
Okay.
where do I share my mail ID?
And then you have a here option is there. If you want a PDF also, so you will get the PDF and make a practice. So not a problem.
Okay, sir.
Okay.
Yes, sir. Yes.
Further. This is a
Okay.
teaching you can.
Anybody else had is in any other queries?
Any queries regarding teaching, learning, which subject you are teaching, if that, what are the MATLAB resources are available. If you are teaching this robotic subject now, we have a very ready-made, very trailer made
One more.
ML expert. You directly start and explaining this robotic system that is available.
Okay,
So
sir.
And sir, please share your email ID. If somebody has any query, they can mail it to you.
Yes, please. Ankit.com.
So can
Tomorrow you can. Tomorrow, please share your email ID.
First mail slide.
tomorrow yes, sir. I will. Right now, I have to tell my mail ID or tomorrow.
I will say near
Sir,
just a minute. Where is
first,
it?
sir will share his email
Where is
ID and
that?
then you can ping it to your query. Okay.
Huh? Yes. Just a minute.
Okay, you are sharing it today, sir, or you will share it tomorrow?
No, today itself I will share with you.
Okay.
Ankit.kumar@designtechsystem.com. So where is a chat box? It's not visible. Yeah, it is available.
So chat box option is not visible to us.
Not visible, no? That also I'm not able to find out. Okay, fine. I will share with you tomorrow. No issue. Ankit.kumar at the rate
You, sir,
designtech.
what you do, sir? You open one Word document and write your email ID, sir. One Word
Okay,
document, write your email ID, sir.
okay, fine.
So that
That's
madam can, whatever the queries he has, he can send you on your
yes.
email
Please,
ID.
on the
Yes, sir.
robotics, I'm highly
I will
interested.
share my queries on your email ID. Please.
Please.
Yes, sir.
You from which college you are? Please tell me. What?
Here, Sanjuni College of Engineering, Kopargaon.
Okay, yes.
Yes.
Yeah. So this is visible.
Yes, visible.
Yes,
Ankit,
sir.
Kumar. All are they small? So tomorrow I'll share the feedback also. DS.
Increase the, sir, font size, sir.
Just a minute.
Yes. Yes. That is fine. Okay, please, the participants, please note down the email ID of Mr. Ankit. And if you have any queries, you can mail him whatever you have, any doubt or queries to Mr. Ankit. He will help you. Or if you have any doubt regarding the product, MATLAB product also, if you want to purchase MATLAB product, you can contact him.
This is the number. This is the mobile number.
Yes,
Communicate through this mail ID.
yes.
Drop the mail. Whatever the contents I have, anything I will definitely support. If you are teaching anything with the MATLAB, in that case only.
Yes.
Okay. Thank you.
Okay. Anybody? Thank you, Mr. Ankit. Anybody else has any queries? Okay. Then we will close the session here. And I thank
One
you
person
again,
has
Mr.
raised the hand. Please take a question. This is the
He
compulsory.
Mr. Sheikh, I think he has been raising the hand from the last 15 to 20 minutes. I think he has already asked you the question.
Okay, fine. Okay, that's good.
Yes, it's over, sir.
Okay. Anybody? Yes, yes, please ask. Hello. Okay. Okay, we'll close the session here only. and we will continue the session from where the sir has said, and we'll start tomorrow at 3 p.m. And tomorrow we'll have a quiz again. We'll have a quiz and feedback, the final feedback. And
Tomorrow is just 1 hour session, sir. Just
tomorrow it will be just a 1 hour session. Okay, so please be at time, and there will be quiz after the session is over, and there will be a final feedback, and then the FDP will be over. Okay, thank you. Good evening. Thank you all the participants for joining. We will meet tomorrow at 3 p.m. Okay, thank you.
Thank you, sir.